Then she takes a bottle with a suspension of magnetic particles, turns on the electromagnet with a foot switch, and applies the suspension of magnetic particles onto the test piece. Already in daylight, dark lines are visible on the surface. The lines can be seen much better under ultraviolet light, and particularly well at darkening the daylight. The suspension contains pigments that cover the magnetic particles and fluoresce under ultraviolet light. The particles run off in areas free from defects, and they are attracted and clustered near defects. This workpiece shows a whole array of cracks. In places of magnetic inhomogeneity, for instance near cracks, the magnetic field lines will locally leave the surface and a leakage field occurs. Now, if a suspension of ferromagnetic particles is applied onto the test piece surface, the magnetic particles will run off at defect-free areas. In places of leakage fields, the magnetic particles are attracted and clustered together, thus indicating the place of the defect. The method works best using a pigment which covers the magnetic particles and shows fluorescence under ultraviolet light. Even cracks can be detected that are not open to the surface but just below it, as long as they are not too far below the surface. But one precondition must always be fulfilled. The magnetic field lines must be perpendicular, or at least at a certain angle to the defect,